Hi all, welcome to another video of the subject Power System Analysis based on the KTU syllabus, and we are on the module 6, and today we are going to learn the transient stability. So as we know, the transient stability of a system is concerned with the study of system behavior for large disturbances. So actually the dynamics of the system under transient state are governed by the nonlinear swing equation. We have already discussed the swing equation, that is h by pi f is equal to d square delta by dt square is equal to pm minus pe. But since the changes in delta, here the values of delta will be changing. Since the changes in delta is very large in the transient state. So we know that the value of delta, that is the torque angle, is the angle between the axis of the synchronously rotating reference frame and the rotor axis. So for a sudden change, the change in delta will be very large. So the swing equation cannot be linearized for a general solution, and so the solution has to be obtained by using any one of the numerical techniques. So we are using the numerical techniques, that is point by point method or Runge-Kutta method, for obtaining the solution. And the most popular methods available for the solution is these two. These the point by point or the Runge-Kutta method. And the transient stability of a single machine connected to infinite bus can be easily determined by a simple criterion, that is called equal area criterion. So using this equal area criterion, we can analyze the transient stability of a single machine connected to infinite bus bar. So actually the computational task involved in transient stability studies can be understood by considering the transient state of a practical system. So for that we are considering a single machine system showing in figure this, that is figure 5.6, feeding energy through a transmission line to an infinite bus. So this is the generator and this is the infinite bus and this is the transmission line, and you can see two circuit breakers are there. So let the circuit breakers shown figure be auto reclosure type. So what is that auto reclosure type? So which means the after occurrence of the fault, of course the circuit breaker will open, and after a certain time it will close back. So in this type, the circuit breaker will open its contact upon sensing a fault, and after a small time it will close its contacts. That is, if the fault still exists, then again it will open its contact to permanently disconnect the faulty part. So this feature is useful in clearing transient faults, because the transient fault exists for a small time, and it gets cleared when the circuit is opened. So then the circuit can be closed for normal operation. So in auto reclosure type circuit breakers, the transient fault, after the occurrence of a transient fault, the circuit breaker will open, and after a certain time it will close its contacts. And most of the auto reclosure circuit breakers will open and close the contacts twice before permanently disconnecting the circuit. So in the majority of faults, the first reclosure will be successful, and hence the system stability is improved by using auto reclosure circuit breakers. So let a fault occurs at the sending end of the transmission line in the system, in the previous figure. That is a fault. A fault occurs at the sending end. This is the sending end, and let the fault be transient in nature and cleared in the transient stage. So hence the circuit breaker will close the circuit automatically after the fault is cleared. So the transient stability study for this situation involves the following steps. Okay, some around 6 steps are there. So the first step is to calculate the transient null EMF and torque angle delta 0 using the pre-fault load currents. Okay, here we know that the value of delta 0. Okay, it is a torque angle corresponding to pre-fault operating conditions. And the second step is determine an equation for power during the fault condition. Let this equation be PE of delta. Okay, if the fault is a three-phase fault, we know that okay, the power transferred to in-feed bus is 0 and the entire power goes to fault. Okay, and the third step is calculate delta of t for various time instant by solving the sine equation. Okay, using any one of the numerical technique. Okay, we can use the point by point method or Runge-Kutta method. Okay, so the initial value of delta for this solution is delta 0. And the fourth step is, let us assume that the fault is cleared when the circuit breaker opens its contact the first time, for the first time. Now P of delta will be 0. Okay, but we have to continue calculating the delta of t by taking previous step value as initial conditions. Okay, and the next step is, that is let us assume that the circuit breaker close its contact and power feeding to in-feed bus is resumed. Okay, for this situation find P of delta and continue to calculate delta of t. Okay, we have to find the P delta. It will change from 0. Okay, and the last step is, now examine the variations of delta of t. If delta of t goes through a maximum value and starts to reduce, then the system is a stable system. On the other hand, if delta of t remains increasing for a specified length of time, then the system is considered as unstable. Okay, as we have discussed in the previous lectures. So we have discussed the transient stability and the occurrence of the fault and about the auto reclosure type circuit breakers we are using. Okay, I hope all of you understand the topics well. So thank you.